am with Best Incorporated, and the reason for us to be here is to go over the revision changes from the current Rev of the J-STD-001 to the new revision of Rev F, and what it entails and what changes have been made and how it's going to affect you as your business is going as we go through this. So, get my screen to work here. So in the book, as we start out, looking at the first pages of it, the first thing that we see here on the screen is that the revisions, they've deleted some of them, the section where it talked about under 1.1 for and the handbook 610. The handbook 610 is actually gone away, so that we won't see any longer, so they deleted that reference. And then 1.2.12 has been modified. 1.3, where it talks about the high classes, the class distinction now for class 3 says high performance electronics, also harsh environment electronic products. So they just added the harsh environment to that as a distinction of the type of class that we're looking at, or as far as what class 3 is. Under 1.5, they've taken out a section there where it says leads to a hardware defect, and they just defined it. And it says where the word shall is used in this statement, the requirements for each class are in brackets. So it's identifying the statement as shall would be the defect. It doesn't go into the other part of it. It's also made the reference under 1.5 where the space addendum will be also the Rev F on it, so it's just J-STD-001 FS. But one thing that has happened that is really going to change how we have to look at the J standard is the use of the space shuttle has been taken out. So any of the references to the space addendum now, you're going to have to refer to the space addendum to see if the clauses has been referenced to identify that you need to look it up. So there won't be any references in the J standard now for that. And it does say here that it contains some different requirements to this document to change the way the paragraph reads. Under 1.5.2, it talks about the hardware, and it changed the disposition where it says it shall be dispositioned when the condition is a defect to it shall be classified as defects and then dispositioned. So they just changed the wording slightly, but it essentially means the same thing to it. In 1.7.1, under conflict, it added the sentence to it at the end of the statement there to say that some examples of documentation would include the contract, purchase order, technical data package, engineering specifications, or performance specifications to that. So that's just an addendum or an addition to that particular statement as far as the conflict was concerned. Under 1.8.1, that has been deleted, the defect, they removed that. They changed the numbering of the others back to pick it up. And in 1.8.3, they added POD to it. So now we have a distinction for foreign object debris. It's a generic term that's for the substance, debris, particulate matter, or other article that's alien to the assembly. So they have added the definition for foreign object debris. Under 1.9, they added the design and workmanship of COTS items should be evaluated and modified as required to ensure that the end item meets the contract performance requirements, and modifications shall meet applicable requirements to the standard. So they've added that statement into it. One thing that is especially good to point out here is that personnel proficiency has now been changed to it being a defect for instructors and operators and inspection personnel for Class 1 if they are not proficient in the task to be performed, whereas before it was not established. So now they've added that as a defect. Goes on to say that objective evidence is records of training to the applicable job function being performed, work experience, testing to the requirements of this standard. These are all how we identify objective evidence. Also changed it for Class 1 again that it's a defect if we don't have objective evidence available for review. Under Section 2, where we get all the different reference materials, they've added 2.6.25 for cathode or conductive anodic filament and the IPC 7093 design and assembly process documentation. So they just added a little bit to it. They've also added under 2.2 the IPC 7711/7721 booklet and the 9202 materials and process characterization booklet. Under 3.2, for the fifth paragraph in 3.2, it says the balance of an SAC 305, where previously it just said lead-free bath. Now they've stipulated that SAC 305, lead-free bath, shall be of the items listed in Table 3-1. The use of other lead-free alloys contamination limits also shall be on agreement between the manufacturer and user, and it's a defect for Class 2 and 3 if it is not. So any other lead-free alloys other than SAC 305 have to be agreed upon. Under 3.3, they changed the flux. Now it's a defect for Class 2 if it doesn't conform to the flux activity levels of L0 and L1 for fluxes. And it also says it's a defect for OR L1 fluxes to be used in a no-clean soldering environment. Flux application goes further under 3.3.1, and it says that the fluxes shall be compatible both from a cleaning process standpoint and from a chemical standpoint. So they want to make sure that the fluxes are compatible both for cleaning and chemical properties. Objective evidence of this compatibility, surface insulation resisting testing, ion chromatography testing shall be available for review. If it's not, it's a defect for 2 and 3. And then it also tells you to go to Appendix C for additional information on that too. Under components and seal damage, it's added, first off, it took out part of it there where it talks about the component lead seal shall not be degraded below the part specs. And it changed it to the component damage in excess of that that's determined to be a minor surface flaw shall not degrade the component below the part specification requirements, or otherwise would affect its form, fit, and function and life expectancy requirements. And this can be determined through document analysis. If not, it's a defect for all 3 classes. So they've just expounded upon that a little bit to add a little bit extra information to it. Now under the visual aids, it says visual aids that define minor surface flaw limits for some component types can be found in the IPC 610. It just adds more to it. Also, the loss of silver palladium metallization shall be a defect in all 3 classes if A, it not expose the ceramic on the terminal face, so if it does, it's a defect. It shall not be greater than 25% of the width or thickness of any of the termination faces, not the end face, or be no more than 50% on the top of a 5 or 3-sided termination component. So it's added the visual aid, it's added more definition to that for visual aids. In section 4.5.1, when we talk about gold removal, now gold removal is performed to reduce the risk of failure associated with the embrittled gold. It says gold embrittlement is not a visually inspected anomaly. In cases where the analysis has determined that there is a gold embrittlement condition, the gold embrittlement shall be considered a defect for Class 2 and 3, and it refers you to the handbook and also to the IPC AJ820 handbook, which gives further guidance on that too. Gold also shall be removed, or it's a defect for Class 2 and 3 now, from at least 95% of the surfaces, and it's added in here, and all through-hole leads that will be hand soldered regardless of the content or the gold thickness. So that's a modification to it where now we have to remove gold layers from any through-hole components. Also, it says for the surfaces to be soldered of soldered terminals, and from all solder cup terminals has been added regardless of gold thickness. So the gold-plated hollow cups or soldered terminals that we deal with, those have to have the gold removed from the solderable surfaces. Also, as a note here, they've added this note that the gold embrittlement can occur regardless of gold thickness when the solder volume is low or the process dwell time is not sufficient to allow the gold to dissolve throughout the entire solder joint. So they're just trying to tell why gold embrittlement is an issue for us. And then they've deleted the section under 4.7 where it talks about non-solderable parts. Under section 4.8.2, before in this section it listed all of the defects as subparagraphs to it. Now the anomalies are listed in a table. So the solder connection requirements are in table 4-1. Here is the table. You'll notice that most of it is the same as what we had before, but there is some additions to this, such as the blowholes or pinholes providing the solder connection down at the bottom, and solder that obscures the stress relief bend has been added into it. And that's a defect now for class 2 and 3 if it obscures the stress bend on through-hole components. And they've added the note 1 to identify what they mean by that, in that the solder in the stress bend is not a cause for rejection, provided that the lead is properly formed, and you can still see the top side radius of the bend. Then we go to table 5-1. This is where we talk about the stranded wire damage. And they've added back in the single conductor now, so that it says for single conductors, no damage in excess of 10% of the diameter of the conductor. And the notes they've added a little bit here, under note 1, they've added a statement, or otherwise designated as high voltage. Whereas before we just talked about it as above 6,000 volts, now they leave it up to you and the user to determine what is designated as high voltage. Also in note 3, they've changed a little bit of the wording for damaged strands to a strand is considered damaged if it exceeds the 10% of the strand diameter, nicks or scrapes or whatever. Then we go into section 5.1.3 where we talk about the tinning of the stranded wires. And they really haven't changed it a whole lot, but they've just changed the order of it. So now we have a subparagraph or a subclause under 5.1.3.1 that covers the tinning of the wire and forming of it. And it says, the portions of the stranded wire that will be soldered shall be tinned prior to mounting when it's used for the attachment to solder terminals formed into splices other than the mesh splice, and it's still optional when it's used for heat shrinkable solder devices. So just put it in a subparagraph now. Under 5.3.6, for terminal mounting, they've just added the word mounting in there for soldering. And the table, they've added the mounting requirement to the table. So rather than just terminal soldering requirements, it says terminal mounting minimum solder requirements. Service loops, they've deleted part of that where it says by the user approved drawing or documentation, and they've changed it to where it are required at initial attachment. So when it's required to be on the attachment originally in the contract, it would be there. And they've made it a defect for all 3 classes if there is not sufficient length available for one field repair. And the figure that it refers to now is figure 5.7 instead of 5.6. So before we had it was not determined or a process indicator for 1 and 2, so now it's a defect if we do not provide the service loop. Under table 5-4, it's added the criteria here where it's less than 90 degrees is now a defect for all 3 classes. This is for the AWG30 wire or smaller when we're wrapping the wire around the terminals. So it just added that it has to be wrapped at least a minimum of 90 to be acceptable for any class. You'll notice that from 90 to less than 180 is acceptable for 1, but not 2 and 3. And only when it's wrapped greater than 360 degrees or equal to 360 is it acceptable. Section 5.4.3 for bifurcated terminals, that's been changed a little bit. They've added the subclause 5.3 or 5.4.3.1 for side routed connections. And figure 5.10 has been changed to 5.9 and split into 2 figures so that the statement in there is removed for the second paragraph where it says, as an exception on Class 1 and Class 2 assemblies, wires and leads 0.75 millimeter or larger may be routed straight through. It's the terminal, the figures 5.9 is the side route, and figures 5.10 is the straight through and staked figure now. So the revisions under the table 5.9 says less than 90-degree wrap and does not contact at least two surfaces of the terminal where the pierce or perforated is a defect for class 2 and 3. If its wire doesn't pass through the eye, it's still a defect for 2 and 3. They've taken out the part where it says and contact two sides of the terminal because it states that previously. Also, the wire doesn't contact at least two surfaces of the terminal is a defect for 2 and 3, but it is acceptable for class 1, and they've taken the note out where it refers to the wrap. Figure 5.13 has been changed to 5.14 because of the addition. Then we go to section 5 in the book under 5.6, and they've added a large area here about jumper wires. This is a new section where we actually address jumper wires in the J-standard document where it wasn't before. So for jumper wires, it says the jumper wires shall be permitted only by the drawing or engineering documentation. We just can't arbitrarily put it in there when we feel like it. And when the jumper criteria for the jumper wire is not specified by the documentation, the requirements of 5.6.1 through 5.6.6.4 shall apply. And these also references additional information found in both the 771121 and also the IPC 610 to it. And then it just breaks it down. So the insulation, it says wire insulation shall not interfere with the formation of the solder fillets, or it's a defect for all three. It goes into the wire routing and how the routing is. You'll notice that it says wire shall not overhang or wrap over the board edge, or it's a defect for 2 and 3. And it shall not be loose enough to extend above the height of other adjacent components, or it's a defect for 2 and 3. These are requirements that we kind of went by before, but they were never in the J standard. When in 5.6.3, it goes into the staking of the wire, and it talks about that as far as how it can be staked. Staking shall be applied to the wires, and it shall not be allowed to touch any moving parts. The staking should be applied such that it is sufficient to secure the wire with no spillover onto the component leads above the foot or adjacent lands or component bodies or in seals that may be sensitive when it talks about the wire staking. The wires also should be staked within the radius of each of the bends. So as we change a direction in the jumper wire, we should put the staking at that point. Also, the staking material shall not overhang the board edge or violate the edge spacing requirements, or it's a defect for 2 and 3. And the staking adhesives, when it is used, has to be completely cured, or it's a defect for all three. Then it goes into the lands under 5.6.4, and it talks about the size of the land. For the land width that is 6 millimeters or larger, then the wire to lead interface and fillet shall be a minimum of 2 diameters of the wire, and that's including the insulation for that. If it's less than 6 millimeters, then it has to be a minimum of 50% of the land width or 2 diameters, whichever is greater. Then under supported holes for the jumper wires, it says that holes with component leads, the wire shall not be soldered into the plated through holes with the component leads, or it's a defect for class 3. Class 1 and 2 is still acceptable to do that. Wrap around the component lead itself, the wire shall be wrapped a minimum of 90 degrees around flat leads, a minimum of 180 around round leads. And some of the criteria where it says 5.4.2.2 do not apply for this. The wire overhang also shall not violate minimum electrical clearance. We don't want the wire to, make contact with other parts. Then under the SMT part of it, under 5.6.6.1, the chip and cylindrical end cap components, the wire shall not be soldered onto the top of the component termination. Some components, it puts a note in here about the touching of the components with a soldering iron. This is primarily for like capacitors. They can be catastrophically damaged internally when the tip touches the end termination of the part. Goes on to talk about gull wing leads and where the wire placement is. Should extend at least 75% of the distance from the edge of the land to the knee. The wire end shall not extend above the knee, though, for gull-wing leads. Also, if it violates metal electrical clearance, it's a defect, and we'll see that repeated for each one of the different styles. If the wire is attached to a J-leaded part, the wire length and solder wetting shall extend a minimum of 75% of the height of the J-lead, and the wire end, again, shall not extend past the knee of the component or the top bend of the component lead. For the castellations, it's 75% of the height of the castellation. And again, it doesn't extend beyond the top of it, or it's a defect for all three classes, or violate minimum electrical clearance. Then we have the Table 6-1 for component to land clearance. This is for vertically mounted components. So under the clearance of radial leaded components that are mounted freestanding, supported by the leads only, they shall be between 0.3 millimeters and 2 millimeters, and the land components of land clearance in the table covers part of that as far as the minimum and maximum. The spacing between the component and the printed circuit board shall not violate minimum electrical clearance, or it's a defect. And when spacers are used with radial leaded components, the mounting shall meet the requirements of Table 6-2, or it's a process indicator for Class 2 and 3. So here's the table. You can see how it talks about supported holes with spacer in full contact, where the spacer is touching both the board and the component, but it's not in full contact with it. It's a process indicator for Class 3 now. If it's only touching one of the two parts, either the board or the component, it's a defect for Class 3. And unsupported holes with spacers in full contact with both the board and the component is acceptable for all three. And if it's unsupported hole with a spacer that's not in contact or not in full contact, it's a defect for all three. And if the spacer is inverted, it's a defect for Class 2 and 3. Still not a requirement or not determined for Class 1. And then the figures, they've changed the numbering because they've added these tables and figures into it. So the tables have been changed. 6-1 and 2 have been changed to 6-3 and 4 and so forth. And the figures were changed because they added a figure 6-1. So 6-1 is the new figure, and 2, 3, 4 are changed to 6, 2, and 3 and 4. The part here where it talks about an exception for Class 2, now this is the solder fill as we had it written for Class 2 items where it said it could be 50%. This has been deleted, and it's been added into the table. It's been removed from this section here, and we'll bring it up into the table here. So under the Table 6-6, it says vertical fill of solder for components that have less than 14 leads. It is 75% for Class 2 and 75% for Class 3. Still not determined for Class 1, though. Then for vertical fill of solder with components that have 14 leads or more, now we have the 50% allowance for Class 2. Otherwise, it's 75% for Class 3. So these are changes that have been made to it, and they're just changing it so that you wouldn't have a radial leaded part that only had 2 or 3 leads and had the less than 75% hole fill. They want to get more fill in the hole, and this changes the requirement for that. Also, they changed the wording. They just took out the original on the 2 for C and E. Other than that, it's pretty much the same. And Note 3, it says less than 100% solder fill may be acceptable and some may not be acceptable in some applications. This is similar to what we had previously. Then when we get to the surface mount under Section 7, they've added in some information here. It talks about designs with vias may preclude the meeting of the fillet height requirements. They've added this here and took it out of the individual requirements where it talked about it in the notes for each one of the termination styles. So now they've put it into the front part of it, and it's been removed further on as we look. Also, the solder fillet may extend from the top bend. The solder should not extend under the body of a surface mount component whose leads are made of an alloy 42 or similar metals. Under 7.1 for surface mount device leads, plastic components, they talk about the plastic components that's used in a generic sense to differentiate between plastic and other materials such as ceramic. It says, unless otherwise specified, the solder shall not touch a package body or end seal. Exceptions are when a copper lead or termination configuration causes the solder fillet to contact the plastic component body, such as in the plastic SOIC family or SOTs and SODs. The space from the top of the lead to the bottom of the plastic component is 0.5 millimeters or less, so they're changing the spacing requirements. Connectors provided that the solder doesn't go into the cavity of the connector, and leadless components where the design land extends past the component termination area, or when it's agreed upon between the manufacturer and the user. So they're just defining that the solder can or cannot touch the package body for those conditions. It also added under Section 7.5 that components with surface and or termination ends or sides that are not wettable by design are exempt from the solder wetting requirements in these areas. So that would include components where the component is cut and the solderable surface is not available to the side of it. Now it's not a requirement for the solder. Also, the solder fillet wetting through the sides or ends of the leads is not required unless specifically stated for those parts. Then looking at Table 7-4, this talks about the chip-style components, rectangular or square end of 1, 3, or 5-sided. They modified some of it. I didn't show the whole table here. They just modified part of it. Where it talks about the minimum fillet height, they've taken out the reference to Note 6. Note 6 has been deleted because this is covered now in the previous statement at the early part of the section. They've also changed the termination length to Note 2, that is an unspecified parameter. And the side mounting or billboarding, they've just changed the notes because Note 6 was removed, so they've renumbered the other notes. And then you can see in the notes there, they've changed some of the wording of it. They've taken out part of it for Note 4 and added in the wording there. So the statement now reads, the maximum fillet may overhang the land or extend onto the top or side metallization, but does not touch the top or side of the component, just to make it make a little bit more sense. And again, the numbering from Note 7 and 8 and 9 were changed to 6, 7, and 8. And Note 8 now is added, says component size may be larger than 1206 if the component is less than 1.25 to 1 width to height ratio and has 5 solderable surfaces. And that's where we're talking about the maximum component height for Class 3 for the side mounting or billboarding. Under Table 7-7 for flat gull-wing leads, they've added in here on the maximum toe overhang, it says that toe overhang is not permitted when the lead length is less than 3 times the width. So that would mean that for SOTs and SOICs that have the short leads, toe overhang is not permitted for those. It still references you to Note 1 for violation of minimum electrical clearance. The reference for Note 6, again, has been removed because it talks about the vias, or actually Note 6 talks about the fine pitch leads. And then you've got Note 2 where they've added onto it, says when lead forming is required, see Section 7.1. And they've taken Note 4 and shortened that to where the solder doesn't touch the package body or end seal. So the rest of that verbiage has been removed. For section, for the butt-eye connections and modified through-hole leads, Table 7-10, this section has been changed a little bit here. They've added a new mounting style to this section. So in this table here, it just says that Note 3 says that for the minimum side joint length, Note 2 has been changed to Note 3 for wetting is evident. And the dimensions, and throughout the book, we'll see this happening more too, where the dimensions have been rounded a little bit so that we don't have to deal with such absolutes when it comes to the dimensional sizing. So instead of having, the 197, it's just now 0.02 for the minimum fillet height. And then figure 710 shows the butt eye connections for modified through-hole leads. And then it adds the section here from under 7.5.10.2, which is for the eye connection solder charge terminations. And it says that these criteria are for components that are designed with a hole or holes in the lead. They bump on the bottom to assure a good fillet thickness across most of the bottom, and an attached solder slug to control the amount of solder. These connections are formed as solder charge leads positioned perpendicular to the circuit land in a butt eye configuration shall meet the dimensional and solder fillet requirements of Table 711 and Figure 711, so this is the addition, and if not, it's a defect for all three. And the top hole of the solder charge termination with 2 holes is not required to be filled. Additional testing such as shock and vibration may be required by the end user for that. So looking at the table here, you can see where the maximum side overhang is not permitted, the minimum toe overhang is not permitted, minimum end joint width has to be 100% of the width of the lead, minimum fillet height, it has to completely fill the bottom hole on the termination. So this is an added to that. And then the lead width just refers you to Note 1. It's an unspecified parameter. And there's a new figure in there that shows the what a solder charge lead looks like. I don't have the picture in the PowerPoint presentation, but I do have, it is in the book. So there's a figure for you to look at. Then we go to the ball grid arrays, and under 7.5.14.1, it added or changed the figures there a little bit just because we added that extra figure. So figure 715 now instead of 14. And it just changed some of the wording. It took out the spacing under solder ball spacing clearance, and it's now just solder ball clearance. And the solder ball offset has been removed. The offset is taken out. As it says, solder ball does not violate minimum electrical clearances. One thing that a lot of people were looking for is the void criteria on the VGAs has been increased. So now we've got 30% or less voiding. This is for the collapsing ball, not for the non-collapsing. And also the hole fill, it says underfill or staking, when it's required, it shall be completely cured. So they just added the when to it. And then they added Note 3 for plating process-induced voids, such as champagne voids are excluded from this criteria. And in some cases, the acceptance of the voids will need to be established between the manufacturer and user. Champagne voids, we really haven't figured out exactly what they are yet. So if any of you know, so far we just kind of think that it's like the small bubbles in champagne when they're referencing it, but we're not quite sure yet. So we're still trying to find out on that. So if you know at the end of this, go ahead and speak up and let us know. Also, figure 715 is talking about solder ball spacing. It's now solder clearance for BGAs. And for non-collapsing ball, the voiding is changed now where voids are not acceptable for non-collapsing solder balls. So that is a change to it too. So we don't have 25% or anything of that sort. Then we look at the column grid array, looking at Table 717. So the solder connections here, the minimum of 270 degree circumferential wetting is required for the portions of the columns that are visible, rather than before it just said external columns will show complete wetting. So they've added a criteria for that. And when underfill or staking material says when required, it shall be completely cured again. So that's for the column grid components. Then for bottom thermal plane components in Table 719, they've changed the early part of it where it just refers you to the lead style for those leads, and it just says now that the criteria for the type of lead termination being used is what we would refer to. And then it's added a few more features to the bottom thermal plane connection. You'll see here where it says thermal plane side joint length refers to Note 1. Thermal plane solder fillet thickness, it says wetting is evident when the fillet is present. And thermal plane void criteria is Note 1 needs to be established between the manufacturer and user. And thermal plane termination width is Note 3 now. It's an unspecified parameter. And also the thermal plane land width is an unspecified parameter. But they've added these in there to give us a better feeling of what they're talking about or what we're looking for the requirements. And we also added a new edge style connector. This is a P-style termination. This is under 7.5.18. And the connections here are formed to components that have a P-style termination, and they shall meet the table requirements. So this table, table 721, is brand new. Maximum side overhang, not permitted for class 3. Maximum toe overhang refers you to note 1. It says no part of the L portion of the termination extends beyond the land. And minimum end joint width for class 3 is 100%, so it has to be 100% of the width. Minimum side joint length is 150% of W for class 2 and 3. Minimum fillet height, the heel and toe, for class 2 and 3 is 25% of the height of the heel and toe, and it just refers to note 2 for class 1. And then it has the notes there for the termination height, minimum side fillet height, and so forth. And then you can see the notes there too. There is a new figure. Unfortunately, I didn't have that figure. I can't use it out of the book because of copyright, but I did find a part and took a picture just to give us an idea of what it looks like. So this is an actual part picture that I took with the microscope. So you can see how it looks like a small p, and that's how come they named it that way. Under 9.1.3, the requirements for haloing, they've deleted the section or the part there, and they've changed it to the distance between the haloing penetration and the nearest conductive feature shall not be less than the minimum lateral conductor spacing or 100 micrometers, if not specified. And the edge delamination, it says edge delamination shall not reduce the physical spacing from the edge of the closest conductive pattern by more than 50% or 2.5 millimeters, whichever is less or it's a defect. So they've added that for haloing. Then it goes into the flexible circuit delamination. It changed that so that it's delamination or separation or bubbles in the cover layer of the flexible circuitry shall not span more than 25% of the distance between adjacent conductive patterns, or it's a defect for 2 and 3. Also for flexible circuitry damage, they've changed that to where there shall not be evidence of tearing, blistering, jarring, or melting of the insulation, and flexible portions of the circuit cards also shall not exhibit cuts, gouges, or tears. Dents or dinks in the flexible portion of the circuit card shall not extend more than 50% of the distance from the edge of the nearest conductor, or 2.5 millimeters, whichever is less. And nicks or haloing along the rigid part of the edges of the rigid flex printed circuitry, cutouts and unsupported holes, shall not exceed 50% of the distance from the edge of the nearest conductor or 2.5 millimeters, whichever is less, or it's a defect for class 2 and 3. So they've changed the wording there a bit on it, gives a little bit more definition of it. Then it goes in and adds 9.1.10 for non-soldered edge contacts. And it says that the soldered area of the edge connector contact lands shall be free of solder, flux, including no-clean processes, and other contaminants. So they want to make sure that even the no-clean flux residue on the gold connectors are removed. There's been no change to the measles other than the numbering. And it's added under 9.1.12 for crazing. It says the crazing shall not exceed 50% of the physical spacing between non-common conductors. And crazing at the edge of the board shall not reduce the minimum defined distance between board edge and conductive pattern. And if the minimum distance is not specified, then not more than 50% or 2.5 millimeters, whichever is less. And this criteria has been added as a defect for class 2 and 3, as you can see in the screen there. Then it adds depanelization for 9.4, and it says depaneling after the soldering shall be done in a manner that does not impart damage to the assembly, and the edges shall not be frayed, nicks or routing shall not exceed 50% of the distance from the board edge to the nearest conductor, or 2.5 millimeters, whichever is less. And loose burrs shall not affect form, fit, or function, or it's a defect for all three classes. Section 10, they've modified this completely. You can see where all of these have been removed and replaced with the following information. So under the coatings for Section 10, it says all assemblies shall be cleaned before processing. After cleaning, prior to processing the assemblies, they shall again be handled to prevent contaminations, or it's a defect for Class 3. Conformal coating materials, the conformal coating materials shall conform to the IPC CC-830 or its equivalent, or it's a defect for all three classes. And then it's added the minimum specification requirements. As far as the mixing, it says the material specification data sheet or other documented procedures shall be followed for the mixing and curing of the conformal coating, and the materials shall be used within the time period specified both for the shelf life and also the pot life for it, or used within a time period that's indicated by a documented system to control age-dated materials. We want to make sure that we don't use old materials as much as possible. And when processing varies from supplier recommended instructions, they shall be documented and available for review so that we can see what's happening, and that's a defect if it's not. The conformal coating shall be completely cured and homogeneous, which is completely mixed. Items exposed to uncured silicon materials shall not be used for processing of any other materials, and an authorized exception is allowed only in cases where the equipment is used for co-curing processes and the manufacturer has demonstrated through system testing that non-silicon material properties have not been changed and design requirements are still being met. And objective evidence shall be maintained for that too. Conformal coating for whisker mitigation. Now this is for the 10 whisker risk mitigation. It says conformal coating requirements used for 10 whisker risk mitigation shall be agreed upon between the user and the supplier. This would cover, the type of coatings, the thickness, and so forth. Under 10.2, it says conformal coating masking material. When it's used, the masking material shall have no deleterious effect, and it shall be removable without leaving contaminant residue. And the dimensions, again, not reduced by more than 0.75 millimeters in length or width or diameter, same as we had before. Under 10.3, the coating application, it says the coating shall be applied only to the areas designated for coverage in the drawings. This is similar to what we had before, and it refers to the keep-out zones and so forth. Under conformal coating on components, under 10.3.1, says when the coating material is applied to a glass body component, the component shall be sleeved when specified to prevent cracking unless the material that we're using has been selected so as not to damage the components or its assemblies in its service life environment. And coating fillets should be kept to a minimum. So the fillets around the parts we try to minimize. Goes on to say that the mating surfaces, electrical and mechanical, of the connectors shall be free of conformal coatings. The mating contact surfaces or surface of brackets or other mounting devices shall not be coated with conformal coating unless it's specified in the drawing, or it's a defect for all three. The thicknesses shall be in accordance with Table 10-1, just as before. And it says coating thickness is a result of the process and is expected to vary on and around the components that may not meet the values of Table 10-1. The thickness is to be measured on a flat, unencumbered, cured surface of the circuit card assembly or a coupon. Coupons may be of the same type of the material as the printed board or may be made of another non-porous material such as metal or plastic. You can also use as an alternate a wet thickness or other measurement as long as we have documentation established on how to do it and so forth. And then with the note, it says, note for Table 10-1 of this standard is to be used for printed assemblies. The coating thickness requirements in the IPC CC-830 are used only for the test vehicles. So here's Table 10-1. These are our thicknesses. And basically, they've changed this very little. It's just the tables we had before. They just rounded the numbers out a little bit, I think, on the inches side. Under 10.3.3 for uniformity, it says coding distribution and uniformity will depend partly on the method, such as, if we're dipping it, how it's going to be controlled and so forth. And it may affect the visual appearance and corner coverage. Some variation in visual appearance of the conformal coating is expected and accepted. So as an example, it says assemblies that are coated by dipping may have a drip line or a localized buildup on the edge of the board. As long as this doesn't affect form-fitted function, it's acceptable. 10.3.4 talks about the transparency, and it says transparency is controlled by the material, the coating material standard, and it shall meet 10.1. Bubbles and voids, it says cured coatings should be free of bubbles and voids, and when present, the bubbles and voids shall not, or it's a defect in all three, bridge non-common leads or conductors, expose one or more conductors, and when the bubbles and voids are present and do not meet the defect criteria, they shall be considered as process indicators for all three classes. Under 10.3.6 for delamination, the cured coating shall be free of blisters and delamination shall not bridge non-common leads or conductors or expose one or more conductors, or it is a defect for all three. Then it adds the foreign object debris. So FOD in the cured coating shall not bridge conductive surfaces or violate minimum electrical clearances between components, lands, or conductive surfaces. Other visual conditions under 10.3.8, the coating shall be free of de-wetting, mealing, peeling, wrinkles, non-adhering areas, or delaminated, cracks, ripples, or fish eyes that bridge non-common conductors. The inspection is in accordance with Table 12-2. And the referee magnification for conformal coating is specified as 4 power. Or it's a defect for Class 3 if you don't adhere to that. Conventional coatings that contain a fluorescing agent should be examined under ultraviolet light to verify its coverage. It's a lot simpler with the UV tracer element in it to be able to see it, because you can just shine the light on it, follow it through. Under 10.3.10, it says rework or touch-up of the conformal coating. The procedures which describe the removal and replacement or manual rework touch-up the coating shall be documented and available for review. And the coating rework or touch-up areas shall meet the requirements of assembly drawings or documentation. If the thickness measurements are required in the rework area, then the validation process shall be documented and available for review. And as a note, conformal coating buildup on or around some component types, such as glass or ceramic body components, may cause damage, and the coating touch-up should be applied as close to the original thickness as possible for those. 10.2 was changed to 10.4 for the encapsulation, and it deleted this part of it for encapsulation. And you can see where it deleted the sleeved, actual leaded component part here, and changed it. Now it says glass body components, sleeved glass body components shall, or it's a defect for 1, 2, and 3, be free from staking material on any exposed glass surfaces, such as the component end face. The staking material shall be applied to both sides of the component, and the staking material fillet shall extend between 50 and 100% of the component length. Minimum fillet height shall be 25% of the component height, and the maximum fillet height shall allow the top of the component to be visible for its entire length. Or it's a defect there for Class 3 on that. For radial leaded, this was changed from F to E. Radial leaded components whose longest dimension is their height. They removed the talk about the CKR capacitors and SIPs. It says the staking materials shall, or it's a defect for 2 and 3, be applied to a minimum height of 25% to 100%. I'm pretty sure this is just the same wording as we had before. We just changed the reference to it as to what letter it's under. Radial lead components whose longest dimension is their diameter or length is now F. Slight flow under the staking material is now 10.5.1.A. Under 10.5.3, it says staking inspection. The inspection of the staking shall be performed and may be performed without magnification. See Table 12-2. And they've taken out the statement where it said the visual inspection may be performed without magnification or up to 1.75 to 4 power for referee purposes. Then we've added another section here under Section 11. This is now witness and torque stripes or anti-tamper stripes. It says that if they're required, the following criteria shall be met. And it says that it shall be continuous between the fastener and the substrate. It will be undisturbed, extend from the top of the fastener or the adjacent substrates as a minimum, and be aligned with the center line of the fastener. If we don't follow these, it's a defect for Class 3. Section 12 was changed to Section 13 now, so rework is under 13.1. And they've added the statement that rework is the act of reprocessing in a manner that assures full compliance to the applicable drawings or specifications. So it identifies what rework is. It's taken out that rework includes hand solder touch-up after mass soldering operations, and it's just the second application of the soldering iron during hand soldering on a single connection is not considered rework. 12.2 was changed to 13.2 for repair, and it says that repair gives us a definition of it now, is the act of restoring the functional capabilities of a defective article in a manner that does not assure compliance of the article with the applicable drawings or specifications. So we're just making it work now, not making it pretty any longer. Then we go into Appendix C. This has been added. This is guidance for objective evidence of material compatibility. They've added a lot of information here for it. I'm not going to go through reading all of it, but it does cover quite a bit here. You can see that. And that pretty much covers everything. So this, as you can see here, how you can contact us. And I'm going to go ahead and open up the mic here so that everybody can talk. Give me 1 second while I get it brought up here. Okay, got the mic turned on again so I can hear you. Well, thank you. I need to bow over and say thank you, thank you, thank you. Okay, so are there any questions?
Good job.
No, good.
Okay, thank you. All of the material will be available to you if you get with us. For those of you that have signed up to this particular webinar, we will send the information out to you in a following email for you. You'll also get in the PowerPoint presentation that we send out to you all of the slides that we had. Because of time constraints, I had to limit the time a little bit. So I cut out some of the slides. There's probably at least twice as many slides in the presentation that you'll receive as what I covered. If you go into the slideshow part of it in PowerPoint, I think it will show up in there as to which slides I showed you compared to the slides that are in the full PowerPoint presentation. So if you have any questions, you can always contact us. We'll be happy to help you out. If there's no further questions now, I'll go ahead and stop the webinar.
Okay, great. Thanks.
Thank you.
Okay, thank you guys. Thank you for attending.
Thank you.